There you go. You keep saying magneticism. No. Okay. Did you read those words in the middle? Did you read the words in the middle?
Yeah,
okay. All right. So that's your 10 again. Now we're going to jump to the redo. Somebody can read that for a couple points. Just read it from your page, though. Okay. It's 15 points when you get done. Close my door, her, because she keeps sneaking off. I don't know. Close that door. Nicole then disappeared. I'm trying to keep. I'm fine with that, but you can't leave my door open. All right. So, go ahead. I'm sorry, Mr. Brown.
A metal rod 0.21 meters long and a mass of 0.0681 kilograms is suspended from two thin flexible wires at right angles to the rod is a uniform magnetic field of 0.569 centimeters to the page. Find A, the direction, and B, the magnitude of the electric current needed to levitate the rod.
Thank you, sir. What page are we looking at here?
803 to 804.
Thank you. All right. So I told you it's 15. Tally up. Crack your book open. You got some notes you got to take from the book. Wonderful technology called textbooks. Go to page, as he stated, 803. And do you see what you got to take down for notes? It's right there in the middle of your face. The green box, orange bar, first part of your notes. Now, this problem requires a paragraph statement for part A of it. How do you know what that is? Once you get done typing that, I need to see everybody on page 804. That's like Ray Goza did. That's the entire problem. Now, I want y'all to type that statement in because it explains the answer to part A. Everybody see what I'm talking about? So after you get that box done, you need to be typing this too, because that's your part A answer. Maybe I should walk around and show you real quick. And I'm going to start working on part B. So the name of the problem is magnetic levity. All right? Part A is, again, you get on your points. So this is your starting notes right here, right? But part A, looking, you gotta write that for the answer. And then I'm gonna do the math here. You know, if I got that, okay. It goes, you know what I'm talking about? Did you add that to your notes? So part A is the problem. That's the answer. You gotta type that. After you type what's in that box. That's the answer part A. You also have to put that box in there. Yep, you got it. You got it. You gotta type that in. Yeah, so first you type this picture. Good. Then you hurry up. Get part A. I'm having part B up there. All right. Let's get started. And when I read it, I should see that. All right. Now, what are we doing, right? Your notes on 803, that box. I was talking about that, right? So let's go ahead and get started on that. We got magnetic force on a current carrying wire. That's the name of the problem. That's the name of this equation, right? You should have typed all that in that box so you know what I'm talking about. Now, how do you use that? How do you calculate for it? You got...
What's that zero called?
That zero called? You talking about theta, the angle? Theta.
You said T.
Yeah, I'm going to explain it again up here too. Theta, that's that, like she said, it's not a zero, it's a theta. So F, all right, is equal to I, which is current, multiplied by, I think that's an L, right? B, L is length, by the way, probably the length of the wire, times the B field that's given, times a trig function Not sure if Miss Alexander taught you some trigonometry yet. And like Miss Melly said, that's not zero. That symbol is called theta or theta. So I'm gonna spell it out for you. This is called theta if you're looking for the Greek letter. Okay? So let's talk about what these are measured in. Again, this part of your notes is covered if you wrote that box, right, on 803. I'm just explaining a little more. So while I'm doing this, I'm supposed to be writing part A's answer down.
The current, that,
You trying to tell me some things you got?
the current, is that the A?
Current is amps, right? You got amps in here. I'm showing you what each number means. So you can probably start figuring it out when you know what unknowns. This is length is always measured in terms of a meter, right? Right? So you can't use nothing but meters with that. We talk about the B field. The B field is measured in terms of a Tesla. And again, this is always just whatever angle they give you in the problem. Has a degree symbol. But that symbol is called theta. All right, so this is it. If you wrote everything on page, 803, right? This is part one of your notes. And you find it on page 803. Okay? Let's box this off and let rock and roll with the rest. Keep in mind, you do have a quiz tomorrow, so I hope you got great notes from Monday to now. Because all the problems are going to be what you already saw. All right, number 2. What are known and unknown values, right? I got me a copy right here. Oh, where's my copy at? Oh, I'll put it on top of the book. So looking at this, it says a metal rod is 0.201 meters long. That's L. Right? And you want to help me do the problem and get points, because all I'm doing was on page 804 at this point. You can start with the known unknowns and figure out what's what. L is equal to, again, we said 0.201, and this is meters. Right? You put all your dimensions. Some people put these numbers up here in their knowns. No dimension. Every time you don't do it, it's -5. That could add up. So please do it right. Then they say you have a mass, right? Well, you gotta understand, you also need another value known as gravity here too. Because mass times gravity will give you a force. All right? So we're gonna talk about it though. So to give you a mass, we're gonna say M is equivalent to, and that's the thing with the kilograms, y'all, 0.0, I think it's 681 kilograms. It says at right angles, right, the rod is uniform. The right angle is 90 degrees. So sine 90 is 1. You don't have to worry about that no more. And this says, hey, you also got a B field here. So I'm going to put this in here so y'all can see it when you do it. So it's theta is equal to 90 degrees. And then they give us the B field. That's equal to, that's the number with the Tesla next to it, y'all. And that's 0.569 Tesla. All right, moving forward. We need to first answer part A. Y'all did that, I hope. Part A, all you need to do is say, hey, what's the solution 1? And you should have all typed it in on page, what was it, 803? That's what y'all typed in, right? Now part B, oh, this is the math part. So part A was more of a, let's talk it out. But part B is, now let's do some math. dad said talk is cheap. All right, so in this case, it's asking us for what? It says find in part B the magnitude of the electric current. That's I. So unknown is, in part B, I is equal to some number, and we calculate it in amps. Okay, box this off. And there we go. All right, so let's go to the next one. Number 3. And you just state your case, what you're doing. All right, so this is for, we'll call this part B. All right? And who's that? Oh, who's going in out the door? Solve for, what we got? I, right? Our current. And then we have to take this equation and use it to tease this I out using our algebra. All we've been doing for weeks and weeks and weeks is algebra. So you gotta be looking like this crazy. Now I have to show you how this works. You might not know it, but force F is equal to, let me just write it out for you. Force is equal to, write this out, I times L times your B field times sine, and it's theta, right? Now I gotta get I by itself. So this is the part where you gotta do some algebra to tease it out. But before you do, know that this is related to another equation. The side of F is mass times gravity. So F equals m times a, gravity is an acceleration. So in fact, you need little g as well there, and that's 9.81 meters per second squared. That's an acceleration. So it means F equals ma, right? If I did this as an arrow, you can see force is equal to the mass times acceleration, okay? Now that means you could say in the next step that mass times the gravity is equivalent to all of this, okay? So let's write it out. I times L times B times sine theta, okay? And then all I gotta do is get I by itself with my algebra skills. This is steps that the book don't show you, so it's why it's hard sometimes. So let's go ahead and do it. We'll write it again. Right? So now let's break it apart. That's a multiplication process, so we can divide a lot of that out and get I by itself, right? So let's do it. Got all this we want to remove away from I, so just divide it out. Okay? What you do to one side, you gotta do the other. Okay, I can cross out my B fields over here, my L's, and my sine thetas. Rewrite the equation. So the new equation becomes, maybe I should have moved that over some. It's just too far over in the equal sign area. I don't like how that looks. Let me move it over. So again, it's going to be over here. L times the B field times sine theta. Okay, that's better. All right, now rewrite. And we have now what we need for I with this. So it actually becomes current is equal to the mass times the gravity divided by length times the B field times sine and theta. All right, now we can put the numbers in and be done with this puppy. So let's go ahead and do that. Our final phase, our final step is to write it out. We got, let's use our values. Mass, we know that was this. So parentheses 0.0681 1, and we'll put kg for kilogram, right? Multiplied by our gravity. I told you what it was here, little g on Earth. Okay, now the bottom. Well, here's our lift right there. Times, what was our B field? It's right there. Times, we got sine theta right there. And that's 90 degrees in this case. So I'm ready to calculate and be done with this. So I is equal to, this is for our part B section. A you got from the book though. You had to type that out on page 803, right? But B, there's a lot of math. So where's my calculator? Use your fraction button. Boom, boom. And then we got what? 0.0681 times 9.81. Come down. Get 0.201 times, we got 0.569 times, get the trig button, sign, and put 90 in there. I get a yield, right? Make sure your calculator's on also degrees, not radians. So 5.84, and it's amps, right? That's all she wrote, ladies and gentlemen. Recording was worth 45 points. It goes to who again? Jamel, who did it go to? You remember?
Nobody.
Okay, you gotta give it away then. Okay. All right.